When metal gets very hot, it turns red, then orange, then yellow, then blue, then white. Why does it skip green and violet?
The phenomenon you're talking about is black body radiation. The name is weird. It comes from the concept to imagine a perfect black sphere floating in space, black to every frequency of electromagnetism, that is to say it absorbs everything. It will keep getting hotter and so must shed this heat energy, but way it emits heat is a modified bell curve of probability drawn on the electromagnetic spectrum, starting with its peak very low on the infrared.
As the heat increases, this bell curve moves towards higher frequencies, as these carry more higher frequencies or shorter wavelengths appear more blue than red. You are right that it appears to skip green and violet. The reason is that the bell curve of light emitted is broad, not a focused frequency like a laser, but we don't see the air and UV, which gives us this order is a little off. But here's an explanation of what's happening at each color. In visible, the peak is low in the ear spectrum.
Red peaking in ear. Yellow, the peak is red, but it is also shedding green if looked through a prism. White, the peak is green, but the peak is now so high and broad all visible frequencies are emitting about the same brightness. Pale blue, the peak is now violet, but it still emits highly in the green frequencies. Edit after this it just gets brighter pale blue. It never shifts violet, but the peak is moving towards higher frequencies.
The filament of an incandescent light bulb is a perfect example. The temperature of the filament, measured in degrees Kelvin, is equal to the light color. We use this temperature to describe the color temperature of LED lights, which replace them. 3000 K is orange, 6000 K is bright blue. These temperatures are 5000 degf and 10,000 degf respectively. This page includes a graph which might help visualize this.
It is a property of all matter, but samples of pure elements will have specific frequency steps they naturally prefer to emit from. You might see flickers of green and blue on a campfire. This is the same. Tricking these atoms to produce only specific frequencies is how we produce the colors of fireworks, the yellow of sodium streetlights, or lasers. Hope this in bullet points: it never goes more violet than pale blue. 2 warm light bulbs are lower than 4000 K.